Man, what a great day here at Henry, good morning. It's great to see you today. Oh my gosh, I've overslept my alarm. Oh, I think I should just go virtual for today. I'm not really sure. I don't think Mr. Scott's going to care that much, but I might just have to do it. Oh, frig, it's AP practice day. I gotta go. I'm late. Gosh, I'm gonna be late. Oh my goodness. Kristen,
Hey,
what is
Brian.
up?
Nothing much, just walking the stats.
Are you running late today too?
Yeah, I'm having a horrible morning.
Last one there's a rotten egg. Sorry about your morning. Jackson, Claire, you guys doing all right back there at home? Good. Everybody else doing good?
Yeah, doing pretty good. How about you, Mr. Scott?
I'm doing great. Had a good weekend. And took my boys out to play some disc golf and finished up grading some of those tests from last week. But anyways, today was going to be question day. I know finals are coming up. So I was going to ask you guys if you had any questions. But before I do that, I'm going to hand back some of your tests, some AP practice, Price. Take a couple of these. Jason, have some tests. Jefferson, you got 100 on all of these. Trey, you're killing the game, son. Jock, my guy. There you go. Kristen, you failed all of them. Jackson, is your mic not working again? Oh my goodness. What to expect. Kennedy, good job, sister. Ian, always crushing the game. Still beating Jefferson and everything else. All right, guys. So does anybody have any questions? I was going to allow you guys to look over your stuff and just to see if you had anything to ask before the big AP exam tomorrow.
I think I have one.
Let's hear it.
Could we go over the big concepts we've gone over this year?
From the entire year?
Yeah.
All right, let's do it. If I were to tell you the average weight of sheep in this pen, would you consider that a parameter or a statistic?
A statistic.
And why is that, Trey?
Because the average weight is only about the sheep in this pen, but not all the sheep.
Correct! If I had gathered all the sheep in this world and calculated the average weight of all of them, that would be a parameter. Remember, P is for population, parameter, and S is for statistic. Sample. Now, someone gave me a quantitative statistic about these sheep right here.
I would say that there's 20 sheep in this pen.
Now a qualitative statistic, Kristen?
Well, Mr. Scott, if you follow me over here to these 3 sheep, and we ordered them from heaviest to lightest, I would say that this sheep is first in 50 pounds, this sheep comes second with 45 pounds, and this third sheep comes last with 40 pounds.
Very good, Kristen. A quantitative number is one that makes sense to do math with and can be measured, while a qualitative or categorical number is a number that does not make sense to do math with and is descriptive. Now, can anyone tell me which type of graphs and charts are for qualitative or quantitative numbers?
I got you. So quantitative data can be shown through dot plots, thin plots, histograms, and qualitative data can be shown through bar graphs and pie charts.
Wow, well, the last question I have is if anyone could tell me if there are any outliers in the weight of these sheep.
This sheep's weight is an outlier.
How do you know that?
I use the outlier rule. If we take the weights of the sheep in our sample, we can divide them into quartiles. Then we can find the interquartile range by subtracting the first quartile from the third. Then we multiply the IQR by 1.5 and add it to the third quartile and subtract it from the first. Anything above or below those values are considered outliers.
All right, let's talk about describing distributions. We will use the acronym SOX. Can anyone tell me what this acronym stands for? Here you go, Price. Jason. Jefferson, you never wear socks, so go ahead and wear them. Kristen. Jock. Trey, you can have a pair. Ken. Ian. Couldn't find any in your size, man. I'm sorry. All right, now, could anyone tell me what this acronym stands for?
It stands for shape, outliers, center, and spread.
Okay. And Trey, how do we decide the shape? Could you come up and show us?
Certainly. This shape would be symmetric, because the tails are symmetric. And this shape would be skewed left, because the tail is on the left side.
Very interesting.
And this shape would be skewed right, because the tail is on the right hand side.
Well, thank you so much for coming up, sir.
Thank you.
When describing a skewed distribution, or a distribution that has outliers, we use median and IQR for center and spread. When we describe a distribution that is symmetric and has no outliers, we use mean and standard deviation for center and spread. All right, so do you guys have any other questions?
Could we go over probability?
Yes. Probability. Well, first I want to ask if you guys remember the two types of probability. Well, I'm going to take that as a no. First probability is theoretical probability. Theoretical, otherwise known as classical probability, is used when we know the probability of something, and we are trying to predict what is going to happen next. On the other hand, statistical probability, or empirical probability, is based on events that happened in the past, and we use those events to try and predict what might happen next. For example, maybe predicting the weather or sports events. Now, Trey, do you remember the law of large numbers?
Yes, it is the more times you repeat an experiment, the more the statistical probability begins to approach the theoretical probability. So if we kept taking the samples of the sheep back there, the more times we do that, the more we're closer to get the actual weight of the sheep of the entire world.
That is correct, Trey. You're starting to remember. Now, do you also remember what mutually exclusive is?
Isn't it when two events cannot happen at the same time?
Yes, that's it.
Hey, Mr. Scott, how do we find the probability of picking a red sheep and a blue sheep?
Well, that's a good question, Trey. First, let's say that the probability of picking a red sheep is event A, and the probability of picking a blue sheep is event B. Then, we have to figure out if the two events are mutually exclusive, or independent, or not. What do you think it is?
I think both are mutually exclusive.
And that's correct. Good job, Kristen. So, to find the probability of selecting a red sheep and a blue sheep, you would multiply probability of selecting a red sheep by the probability of selecting a blue sheep, given that you already have a red sheep. How would you find the probability of selecting a blue sheep or a red sheep?
I think you would add the probability of selecting a blue sheep and the probability of a red sheep, and subtracting the probability of selecting a blue and a red sheep.
Very good, Trey. Now, to help us visualize this, we can use a tree diagram.
Do you mean this type of tree?
No, you silly goose. This is a tree diagram, and it will help us visualize how to calculate the probability of selecting the sheep we are looking for. To start off, what is the purpose of a confidence interval?
Confidence intervals are used to estimate a parameter.
So what do we call the statistic from a sample that gives a single value estimate of a parameter?
The point estimate.
Good. After we get the point estimate, what do we do to get the interval?
Add and subtract the margin of error to and from the point estimate to determine the width of the interval.
That is correct. Kristen, how is the margin of error found?
Well, that one's easy, Mr. Scott. All you gotta do to find margin of error is multiply the z-score times the standard deviation.
Wow. Can anyone tell me what the confidence level is? Trey?
The overall success rate of the method for calculating a confidence interval that includes the true parameter.
And how is this level interpreted, Trey? Kristen?
Well, we would say it like this. We are blank percent confident that the interval of blank to blank captures the actual value of the population parameter in context.
Very good. I like how you added in context, and the blank sound effects were great.
Thank you.
What two things impact the margin of error, Trey?
The critical value and the standard deviation.
Okay, and a couple more questions. Before we construct a confidence interval, what conditions must be met?
Well, we use the acronym RIN for random sampling, independence, and normality.
That's right. Then, we use a formula to get the interval. Does anybody in here remember the formula?
Yes, I do. It's the statistic plus or minus the z-score times the standard deviation.
Very well done, Trey. Remember, the methods are one prop z interval, and this is for p, one sample z interval, this is for mu, and one sample t-test, which is also for mu, but it's sample means.
So real-world applications of statistics could be used in weather reporting.
There's a 100% chance of rain today. Wow.
Another application could be a sports broadcaster.
There is a 0% chance that the Jets will win today.
And finally, we could use statistics to predict the action of stocks.
For example, if Coke has been performing really well lately, according to its percentage of increase versus decrease on the Dow Jones scale, we might want to invest into it. Some things to expect from your AP Statistics class would be nothing but learning something you've maybe never studied before. That could go between even just as simple as learning how to play a hand of poker. Also, just having one of the best teachers ever, having tests every week, quizzes every day. Just kidding. Having homework balanced between every other night, having great classmates, and enjoying class overall with a great teacher and a great subject that teaches you a lot about life. Thank you guys so much for watching.